I have what I just kind of grouped similar types of figures here. So I have three-dimensional solids here. These are polyhedrons because if you notice, no matter which one I grab, each one of these is made up out of flat polygons, right? So if I were to talk about, say for example, cylinders, right? Are each of the sides and faces of this cylinder polygons? The answer is no, right? Circles are round, right? The smooth surface around the side here is round. So these are not polyhedrons, all right? Polyhedrons are made up of flat polygonal faces. So since these have round edges and round parts to it, these are not polyhedrons. So what I wanted to do is focus on some of the vocabulary because there's a lot. All right, so the first thing I wanted to ask you is, well, what type of solid is this? Is this a pyramid? No. Is this a cylinder? No. Is this a cone? No. So I'm hoping that we're thinking this is a prism. Now I want you to understand why this is a prism. This prism has two bases, okay? And each base is parallel to each other, if you notice. As I stand it up on its base, one base is on the bottom, the other base is up top, okay? Base doesn't mean bottom. So if I turn here, if I grab, say for example, this prism right here, right? The top of this has 1, 2, 3, 4, 5, 6, 7, 8 sides on it. So this top base is an octagon. The bottom base is also an octagon. If I knock this over, what shapes are the bases? Well, they're the same, right? The bases are the congruent parallel polygons, okay? So even if I lay this down, you know, even if I lay that down on its side, on one of its lateral faces, the bases are still these two sides here. So whenever I try to picture a prism, I always want to picture it standing up on its bases. So first and foremost, I want to identify what type of prism this is. Now, in your notes, I posed 4 questions to you. The first question is this standing straight up? You know, even if I knock it down, you know, I still want to think of, you know, the bases are still parallel to each other. But is this standing straight up or is it crooked? So, in my opinion, this is standing straight up. That would make this a right prism, not oblique. All right, we'll talk about oblique in a few minutes. Now, the bases are, there's 2 of them. The bases have 1, 2, 3, 4, 5, 6 sides on it. So each of the bases are hexagons. So we could also say this prism has hexagonal or hexagonal bases. All right, both of those are the correct way of saying it. You just pick which way you like. All right, so I have a prism. Why is it a prism? Because I have 2 congruent polygonal bases. The bases are hexagons, so I would call this a hexagonal prism. It's standing straight up. So I would call this a right hexagonal prism. I told you, there's a lot of vocabulary in this section. Now, the last thing I want to talk about is the base itself. That looks like a perfect hexagon. That looks like it's equal angles and equal side lengths, right? So since this base is equilateral and equiangular, we say that that is a regular hexagon. It's perfect. So lastly, the 4 words that I would use to describe this prism would be a right, because it stands straight up, regular hexagonal prism. Regular because the base is perfect, equal sides, equal angles. Hexagonal because it's a hexagon, and prism because it has 2 bases. I want to continue with the vocabulary here. So if I grab this particular prism, right? So first of all, how do I know it's a prism? Well, I'm going to have 2 congruent parallel bases, right? And those bases have 8 sides on them, right? So it's like a stop sign. That would be an octagon. So if I wanted to name this, there's actually 4 words I could use to name it. I would call this, now 4 words, a right regular octagonal prism. Now there's a couple other vocabulary words we need to go over real quick. So let's talk about vertices. Vertices are corners. Now, if I just count on the top, I'll have 1, 2, 3, 4, 5, 6, 7, 8 corners, 8 vertices on the top, and guess what? 8 vertices on the bottom. So I have a total of 16 vertices. Now, let's talk about edges. Edges are segments. Edges are these little lines, right? So from this vertex to this vertex, that would be called an edge. From this vertex down to this vertex, yet another edge. So what I want to do is I want to talk about the types of edges we might have. So guess what? If I look on the top here, right, I have this octagon. I would have, let's see, 1, 2, 3, 4, 5, 6, 7. I would have 8 little segments on top. Those would be called base edges, right? 8 base edges. So guess what? If I flip this over, wouldn't we have another 8 segments up here? 8 base edges here. So I would have a total of 16 base edges. But now, on the sides here, notice that the octagons are connected with these rectangles, okay? So if I just look right here, this rectangle right here is called a lateral face, okay? So if this segment right here is a base edge, well then this segment coming straight down from one base to the other is called a lateral edge, okay? So how many lateral edges would we have? Well, I would have 1, 2, 3, and I would go around the figure for a total of 8 lateral edges. 8 base edges here, 8 base edges here, and 8 lateral edges would be a total of 8 times 3, 24 24 total edges. Now, finally, let's talk about faces. Faces are flat, two-dimensional shapes, polygons, right? So in this case, I have 2 different types of faces. I have the octagonal base twice, right? And then we also have lateral faces, okay? I usually like to say lateral faces connect the bases. So how many lateral faces would connect the 2 octagons? Well, that's pretty simple, right? I would just have 8 of them, right? 1 coming off of each base edge, okay? So to be specific, how many bases? 2, right? That makes it a prism. How many lateral faces? 8, right? Because there would be 8 rectangles, 8 lateral faces connecting the bases. But how many total bases? Well, that would be the 8 lateral faces going around plus the 2 bases. So for a right, regular, octagonal prism, we would have a total of 10 faces. 2 bases, top and bottom, and 8 connecting lateral faces. Okay, so let's look at a specific example here. As you can see, we have a picture of our solid here, all right? And we're gonna make some assumptions here, but basically I wanted you to take a look. We got a long list of questions to answer, but basically we'll just be counting things and naming parts of this solid. So the first one says, classify the solid and be specific. If we were to pick this prism up and stand it on one of these pentagons, then it would stand straight up. And as a matter of fact, you can see the right angle here that shows that this would be perpendicular. So the first word I'm going to write down is right. Okay, at the end I'm going to put the word prism. Now, I want to describe the bases. So ladies and gentlemen, I colored them in yellow. How many sides does each base have? 1, 2, 3, 4, 5. So this is a pentagon. So this is a right pentagonal prism. But the only other thing I want to ask you is, does this pentagon look perfect? Does it look regular? Is it equilateral and equiangular? I think it looks perfect, right? So we're going to assume that all 5 sides are equal length, all 5 angles are equal. So it's a right, regular, pentagonal prism. So I want to name a vertex. As a matter of fact, guys, I'm going to go around in blue, and I'm just going to color in every vertex. Okay? A vertex is a corner. So how would I name one of these? Well, I know a lot of times we use 3 letters to name an angle, but all we're going to do is try to name a corner. So if I wanted to name this vertex right here, I would just call it vertex B, or vertex C, or vertex R. So I'm just going to use 1 letter. Okay? The next part says to name a base. Well, I have both bases colored in yellow, so all you do is literally just list the letters in order. So I'm actually going to go A, B, C, D, E. So I'm going to name this base as A, B, C, D, E. I could have called it D, C, B, A, E. I could have called it E, A, B, C, D. It's your call. Now, it says to name a base edge, and the next one is a lateral edge and lateral faces. So here's what I want to do. I want to take, I don't know, let's see. I want to take green, right? That might look the same, but we'll see. I want to take green. And guys, what am I tracing right now? From C to B, B to A to E, and then over here, S to I to R. I'm connecting segments. I'm connecting two dots. But the green ones that I just traced are on the bases. So what we would call those would be base edges. So if I call this right here, DC, a base edge, I'm gonna write DC, but I'm gonna put a line segment above it because it's a line segment, right? I could have also picked a base edge on the other one. So maybe I'll just call this, I don't know, SM or RP or PR, right? So I'll call this one PR, okay? Name a lateral edge. Now, here we go. All right, so I'm actually gonna skip ahead for a second. I'm gonna go to lateral faces. A couple minutes ago, I said lateral faces connect the bases. So what I wanna do here is I'm actually gonna use pink and I'm going to draw connecting segments from one base to the other, okay? So in pink, what did I just trace? I traced, those are lateral edges. So again, a base edge was written like a segment. Same thing, lateral edges. So BP is a lateral edge. So I would write BP, put the segment bar above it. CR, DI, ES, and AM are also lateral edges. Finally, I'm gonna pick this face right here, okay? Which is what shape, right? That's gonna be a rectangle. So name a lateral face. Well, I just highlighted it in pink. Now this lateral face is a rectangle. So I'm gonna just literally list the four letters in order. So I'm gonna call this BCRP. So the lateral face, BCRP, is one of the lateral faces. All right, guys, now the rest of these, we're just gonna count. So how many total vertices? Well, how many dots? 1, 2, 3, 4, 5 on one, 6, 7, 8, 9, 10 on the other. I have 10 total vertices. How many lateral edges? All right, now be careful here. Lateral edges are not on the bases. Those are called base edges. So the lateral edges are right here. 1 in pink. 1, 2, 3, 4, 5. There are 5 lateral edges. How many base edges? Well, base edges are the segments on the bases. So I'll have 1, 2, 3, 4, 5 base edges on one, and then I'm gonna have 5 on the other. That'll be a total of 10 base edges. Now look at this, how many total edges? So that's gonna include lateral edges and base edges. I'm just gonna add them together, right? So that'll be 15. And if you just look up here, you'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, ladies and gentlemen, how many bases? Well, I have them shaded in yellow. Every prism has 2 congruent polygonal bases. Finally, how many lateral faces? Well, those are going to be the rectangles that connect the bases. Lateral faces connect the bases. So there will be 5 of those, all right? Just like this one I have highlighted in pink. And then finally, how many total faces? Well, think about it. That's going to be my bases and lateral faces together, which would be 7. Right? 5 rectangles connecting the 2 bases. All right, ladies and gentlemen, I hope this helps.